following two examples are a few more trickier examples, but here they've actually given us the shape of the graph to have a look at so that we can draw the reciprocal. So here, let's have a look at example 13a. Example 13a is from Cambridge, and we've got two graphs that we can have a look at, and they've even given us a few points to work with, so isn't that nice? So here, let's have a look at this question A. So this is our original function. If you have a look, we've got zeros at -4 and 4. And we've got a local maximum here at, that's -3, -3, 2. And we've got a local minimum here at 3, -2. So these are 2 points where either side of the function of it, we've got, it's a biggest value, the biggest value on the left-hand side here, and it's the smallest value on the right-hand side here. Okay, so what happens with our reciprocal function? First of all, let's find our asymptotes. Our asymptotes are where the function is equal to 0. So let's go, if you have a look, we've got a 0 at x is equal to -4. I've also forgot about 1, 0 when I talked about earlier. We have another 0 at x is equal to 0. So here, I've got another asymptote. I've got a final asymptote at x is equal to 4 on the other side here. So we've got 3 asymptotes, x is equal to 0, x is equal to -4, and x is equal to 4. Okay, so we've got our asymptotes there. We can look at the signs of on either side. So here we've got a negative, we've got positive, we've got negative, we've got positive. So our reciprocals are going to have the same sign. That's our next part. Then we're going to check for negative when x goes to -infinity or positive infinity. So here, what we have is, well, if you have a look at the graph, original graph, over this side, we go f of x goes towards positive infinity. So what that tells me in my reciprocal graph, it's going to go towards 0. And the same way, on this side, f of x is going to go towards negative infinity. And so our original graph, reciprocal graph is going to go towards 0 on that side. Okay, the other thing is, if we have a local maximum or local minimum for our original graph, we're going to have a local minimum or local maximum. So let's start with this local maximum over here. This is the local maximum on my original graph, and it's at -3, 2. So on my reciprocal graph, instead of having a local maximum, I'm going to have a local minimum. So the local minimum is going to be at 1 over the y value. So here, instead of having a local maximum at -3, 2, I'm going to have a local minimum. So this is a local minimum at -3, 1 over 2, because I have to take the reciprocal. In the same way, I have a local minimum over here. So I'm going to have a local maximum on my reciprocal graph at 3, -1 over 2, because I have to take a reciprocal of my y values. Okay. Now, the other thing I said was when we get to closer and closer to 0 in my original function, the reciprocal is going to get really, really big. So if you have a look on this side, it gets closer and closer to 0 here, and so it's going to go towards -infinity. On this over here, on the other side of my asymptote, it's going to go towards 0, so I'm going to get a positive infinity over here, and that repeats itself all throughout like that. And so using that, we can actually graph the reciprocal function. So let's do that. On this side, gets closer and closer to 0, and it goes towards infinity. That's what that first part tells me. In between -4 and 0, we start, because the original function is at 0 over here, we start at infinity, we go down towards this local minimum because we originally had a local maximum, and we go back up to infinity. On this side, between 0 and 4, we started near 0, and so we go up towards this, to this local maximum, go back down, and then we go up here, and so we get graph that looks like this. Okay, and that's what we get. So I'm going to just clean up a bit just so we can see this a little bit clearer. Yeah. Clean up that. Okay, and so that's what we end up getting for our graph here. So we have our original function in the black, and our reciprocal function is over on top in the red. Okay, so that's us going through those steps there. Okay, I'm going to go through this last example, and I understand. Oh, hang on, we have to do the domain. Now, the domain, we don't have x values at those reciprocal, our asymptotes, so x is not equal to -4, x is not equal to 0, x is not equal to 4. We can write that in interval notation, so -infinity, -4, union with -4 to 0, union with 0 to 4, union with 4 to infinity. And so that's what our domain is for this question.